This is an agarose gel electrophoresis simulation. I'll put the website there so you can check and play with it by yourself. So we have different wells loaded with DNA, and as the time passes, they'll just go. And for each well, before the DNA, before we operate it, we can touch these and then see what kind of molecules there are. You see they have different sizes, and when we operate, time as like 2 hours passes. This will be how a typical gel looks like. Here, the ones here will have smaller size. You see, the ones here will have much bigger size. For example, these ones, yeah. For example, these ones are those ones, blue ones. Okay, and then we have the dye. This dye is bromocresol blue. Usually it goes at the very front, and then it tells you when to stop the gel and where approximately the bands are. And you can see some bands are more concentrated compared to the others. For example, this one. And this highlight coming from it is due to the concentration. So we can change the concentration here. If we make it concentrated, then they get stronger. But if your DNA concentration is really, really too much, then there will be a shape like this. You will see like that. So if you have such a thing, then what you can do is to extend your wells. Let's try if we extend our wells. First time I'll try. No, we can make them smaller. Yeah, okay. And another thing with the speed of migration, other than the molecular weight, is the shape of DNA. So as the shape goes linear, it'll go a little bit faster, and you'll see how the shape is. Usually the DNA is almost always, I think, like circular, but sometimes for some reasons, I think they are not so clear. It also depends on the size of the DNA. Then it can become more linear. So then they will travel a little bit faster. Okay, what else interesting is sometimes, especially the concentration is high, you start to see a band with a higher molecular weight. So this usually happens if there's aggregation. So if your DNA aggregates with each other, for some reason again, you will have other bands. Usually it's not the case, and if it is the case, you don't have that strong band. But it can happen. Very, very common thing is to have a ladder here. Let's see. This is due to the degradation of your product. If you have DNAs or something like that, there will be degradation, and we call it ladder. You'll see if it is too much degraded, the molecular weight will be also very less, and you can see here how the shape changes, and they will start to go fast, much faster. You'll probably see this in your PCRs in real life. What else should I show you? Okay. And then sometimes, or very seldomly, when you look at the gel, you might be shocked because you will see a picture like this. It happened to me, it happened to many other people. When preparing the gel, if you mistakenly use water, this is what happens. So if you see such a picture, you can almost make sure this is due to using water to prepare gel instead of TBE buffer. with tie buffer and TBE buffer, it doesn't make real difference. They're very similar. And sometimes, especially when loading the gel, you can damage the gel, you can make cracks. If this happens, what it seems is like, depending on where you made the crack, for example, it's here, then the migration will be like that. So you will have zigzags. I also encountered this before. And like maybe 2 times in my life, what I saw was also like the bands were going to the wrong direction, like this. You can imagine why it is like that, because you put the plus and minus to the wrong place. But usually this doesn't happen. That was it. The aim of this presentation was you will do a lot of PCR, especially at the beginning. You will have a lot of problems. This is a simulator you can use. And when the problem happens, you will faster know what the problem is without asking anyone. Take care.